whenever I come back to this student organization that I used to be involved in, hold on, pause.
Okay.
So, it's always a reason, or it's a good excuse for me to sort of reflect on what was school like back when I was here as a student versus now, and what were computers like, and what was programming like, and all that stuff. And I started thinking about how fast computers are today compared to how they were back then. To be very specific, back then was 1989 to 1993 or 4-ish. And I say ish because I sort of dropped out. I sort of faded away from the school at some point. But I showed up in fall of '89. So back during that period, sort of toward the end of that period, this was sort of what would have been considered a badass computer at the time. This is the CM5 connection machine. There was one of these at Berkeley in 1992. I, being an undergrad, was not privileged enough to have any access to this thing at all, right? This thing was reserved for graduate students and faculty who were doing parallel algorithm research. And basically the way it works is this is just a really tall box full of tons of cores. I'm not sure how many there are per box. I think it might be about 100. This is an actual photo from a really ancient EECS website of the actual box that was here. I believe this one was in Evans Hall. So this all dates back to before this actual building was built, right? So we did most CS stuff in Evans or Corey at that time. But the way this computer was designed was so you could string a whole bunch of them together and network them and get a faster and faster computer, right? And so something of this size, this is probably a PR shot from Thinking Machines, something of this size would rank as a top supercomputer in the world. Here's the June 1993 list of the top supercomputers in the world, and the top 4 are all connection machines, consisted of a bunch of those boxes strung together. And you can see how fast they were at Los Alamos, which was probably used for simulating nuclear explosions or something, who knows. 131 gigaflops. That sounds fast, right? So this phone that I'm holding right here, very portable, a lot more portable than that giant computer box, is, if you look up the stats on the web today, 172.8 gigaflops, which would make it easily above the top computer on this list. Now, there may be a little bit of confusion involved in here because I think this is a little bit of a PR number, and it's a 16-bit floating point gigaflops maybe. So you could divide it approximately by 2, in which case you've only got 85 gigaflops, at which point you're a sad number 2 on the top supercomputer list of the world list with June 1993. So things are really fast. And that's just a phone, right? And think about all the computers we have access to today. This laptop that I'm running this presentation on, which is not doing much right this second, it's showing this very boring image, is way faster than this phone, right? I can show you how much faster it is, actually. I have a benchmark here that I'm going to run. So opening this image, and let's see what the... okay, eventually, wait, can I, no? Okay. So that took about, 10 seconds or something. I didn't time it to pull up this really stupid image. And everything here was hot and in the cache and stuff. I was going to reboot before the presentation to get the full experience of it being much slower, but I didn't want to reboot because now there's a Windows update pending, and God only knows if this computer would actually successfully reboot, or if the presentation would have to be scuttled, right? Now, so what's going on here? The job, by the way, this program has the audacity to install itself as the default viewer for all bitmap files when you install it. So you double click on an image in Windows and that's the experience at best, right? It actually was worse a couple weeks ago for weird software complexity reasons that I don't understand. Now the very ironic thing is the very first thing that this program does is display a freaking image. Okay, watch how fast this comes up. Boom! And then it's sitting there doing a bunch of garbage I don't care about forever. And then eventually I sort of see an image, and I still can't do, okay, now I can do something with it. By the time this panel on the right comes up, it's done. So That's not great. That's not great. That's all I'm going to say about that right now. So the laptop I'm running this from is potentially much faster, but in practice it usually is not that fast. In practice, the experience of using programs on a laptop or on a phone, especially if you're on Android, is really not great. So now the warning that I have for you is that the rest of this presentation is not particularly lucid or well thought out. It's just me being angry about a lot of things. And we'll leave room for Q&A at the end, and maybe one of the questions will be, well, what was the point of all that? But I'll try to make it at least clear enough that you understand what I'm saying amid all the frothing at the mouth. So I'm talking about the mid-90s, and that was the rise of the web. So the World Wide Web did not exist when I showed up in fall 1989. In like 1991, I don't remember exactly, one of my friends, Pei Wei, was working on a web browser when like nobody knew what that was, even in the computer science department here. It was a very niche thing, right? Toward the middle of the 90s, you started having the web become a more widespread thing. Back then, you could click on a web page and it would take a second and open, which is about the experience of the web today, especially if you don't run an ad blocker. Now, there is one difference, which is that we had way more general internet outages back then. Like, I don't actually know what happens at this school, but back then, the internet might go out for like a minute in the middle of the day for no reason. Okay, so maybe that still happens. It doesn't happen at my office very often. But aside from that, the experience is about the same. And why is that? Like, this is bigger than the biggest supercomputer in the world, and yet the web is still kind of lame. We do draw more stuff, but if you were to extrapolate that level of amplification of computing power, like the web should be amazing and instant, right? It should respond to you immediately. It should feel, if any of you guys have tried like a VR rig that is running at 120 hertz and has all sorts of crazy tricks going on to minimize latency, like that's what the web should feel like. I mean, maybe in 2D, but it should be that responsive, and it totally isn't, right? Why? What the hell are we doing, right? So here's an interesting question someone asked on Quora. Why does Twitter need 300 employees? I'm just curious. What is the organizational breakdown? Blah, blah, blah. Because it seemed crazy when this was posted that Twitter had 300 people to do such a simple website. Okay, this was a few years ago, though, because Twitter is a lot bigger than 300 employees. Well, first let's read the answer that was given, and I've erased the name of the person who posted this, but it's somebody who worked at Twitter. And she said, well, it's about half engineers, not including operations. The rest is sales, designers, product managers, accountants, legal, recruiting, and HR. As to how big we're going to be, as big as we need to be. Edit. I remember my housemate was once incredulous as to why we needed so many engineers for such an apparently simple site. 1, Twitter's not as simple a website as you think. Keeping Justin Bieber from dominating the trends and user recommendations are 2 examples of non-trivial features. 2, like Facebook, the core functionality is simple and most people could do it in a weekend, but getting it all to work at scale is hard. I firmly believe we need every single engineer we have here, and we need more. Apparently they did. We'll keep going into this explanation. Here's a rough breakdown of where our engineers are. Internal tools, including the Help Center, the Twitter admin, the A/B testing framework, etc. Infrastructure, performance, Rails tweaking, writing job daemons, API platform relevance, whatever. I'm going to go on. I'm not going to read the whole thing. But it just lists a breakdown of like all these different things that one could do. We won't analyze it yet. Here's Twitter now. Well, this was Twitter maybe around their peak. They just laid off about 350 people, so they're probably toward the mid-3000s. And you can say, wow, that explanation really was convincing, even though I didn't read the whole thing. There are all those things that you have to do. I hadn't thought about that. But you can look at examples of some other companies. So for example, SpaceX is around 4,500 approximately employees, and they build and launch rockets into space and then land them on the ground, which has never, and like dock with the International Space Station. How is Twitter remotely of that same scale of effort, right? It isn't, I claim, right? I've been on Twitter since 2010, which I felt like a little bit of a late arrival to Twitter. I was putting it off, like a lot of other people in the games industry were on it at that time. Let's look back at this graph. In 2010, they had 130 employees in January 2010 when I joined. I can tell you from my day-to-day use, it's basically the same website. It just has a few more things that I really don't want, right? But they've gone from 130 people to 3,900 people. Let's assume that it's about half engineers. It's probably more than half back here, right? Because they haven't like staffed up to have sales and all that. But call it 130 engineers to 2,000 engineers to still do basically the same thing. It's a little bit crazy. What is happening? So you could say, well, maybe they're building a very high quality product. But I can tell you that's really not true. So yesterday while I was working on this talk, right, I made a tweet and I misspelled a word, which happens all the time because you're typing really fast. You can't edit tweets. So I deleted it and I said, oh, if I delete it and paste it in really fast and fix it, then I'll get it out and it won't go to that many people. So I deleted the tweet and then I was trying to paste it in and edit in the box. And this "your tweet has been deleted" thing kind of pops down from here, and it's covering the box where you need to type, and it wouldn't go away. So I was like, what the hell is going on? And I kept trying to make it go away. I tried scrolling down on the page. I eventually had to reload the page and then paste the thing. And by then, my whole, like, I'll slip in the quick change tweet, it was really a little bit of a lost cause at that point. So all those engineers are not working on software quality, as near as I can tell. The software is still basically terrible, right? It's basically the same thing it was in 2010. It does a few things a little bit better. It does some things a lot worse. Now they try to move buttons around on you, like they put that moments button up there where you used to click all the time in order to try and get you to click on it. So a lot of those engineers, it was probably 10 people's job just to move that button. I mean, I don't even know when you have that many people what they're doing. Okay. So one theory is, okay, maybe it's really this complicated. Maybe, okay, you've got to do all that stuff. That's a lot of people. But you know what? I just shipped a frickin' video game on a couple of platforms. And if I were to list out all the different things we did to ship that, it would be a really long list. I could certainly make you a lot longer list than this if you're trying to compete for length of list, right? Like, frickin' internationalization. I did internationalization for 16 languages on this game, including programming for frickin' Arabic, which was really annoying. Sorry for people who speak Arabic, but the thing that makes it annoying is it's right to left, whereas most languages we deal with are left to right, and like, so every screen, never mind, I won't go into it. The language itself, I'm sure, is very beautiful, but when you've got like 2 weeks to make it work, it's like, oh my God. Fortunately, well, there are some libraries that help you a lot with that. But the point being just, you know, like, okay, internationalization definitely is a thing you have to do, but why do you need a department for that? It doesn't, like, especially an engineering department, it doesn't make sense. All right, so alternative thesis to the fact that it's this complicated is like maybe people at Twitter don't really know how to program that well. That is not the most incendiary thing I'm going to say at this talk. So. They're not really alone. So, you know, that poster said, like Facebook, we have a lot of things we have to do. Facebook is also a website, right? Facebook does a lot of things, right? They put out a lot of open source software. They release a number of things. A while back, there was a situation on Android where they had to release a patch for certain versions of Android because their Facebook app would not run otherwise. And it was a very controversial thing. They were doing things that were a little bit nasty and could cause problems for users. And there was this explanation posted for why. And the guy says, I didn't block out his name, sorry. But the guy says, Facebook is one of the most feature-rich apps available for Android, with features like push notifications, newsfeed, and an embedded version of Facebook Messenger all working together in real time. The complexity and volume of code creates technical challenges that few, if any, other Android developers face. I don't know if this dude has ever seen a video game, but like anybody from the game industry, even beginner indie game developers would look at like push notifications, a news feed, and an embedded messenger and like laugh that off the face of the planet as being difficult to do. Like there's just, however, right, having said this, I'm not denying that possibly it is very difficult to do at Facebook within the organization and engineering culture that Facebook has created. So he may be partially correct in his statement, but it's many people I know read this and think it's very embarrassing for Facebook. And Facebook has done a number of things just like this. There's a certain something. Let's not go too far. Anyway, so there was another blogger who looked at the Facebook iOS application, which is roughly the same application, and someone had noticed, well, this application is very large. It's over 100 megabytes. Why is it so big? It doesn't have that many graphical assets or audio assets or things that you would usually expect to make something big. And they were like, oh, well, the binary is really big, and I wonder why. And so he dug into it, and he found that there's over 18,000 classes in it, right? So, it's some kind of Java app where they decided to factor it in an extreme way. And there's 18,000 classes, and then the thing that caused this Android problem is that there's a fixed size buffer on Android that holds the address of functions, right? And they made it much bigger than they thought anybody would ever reasonably need, right? But if you have 18,000 classes, you're going to overflow that buffer, right? So there was a whole discussion about this. One guy from Facebook, he wasn't really a spokesperson for Facebook. He was just a random engineer, so I don't want to pick on him too much. But he was just like, he was defending it. He was like, oh yeah, it's a really sophisticated program, right? Android cannot handle the intensity of this program, right? It's freaking Facebook. It shows messages from people you barely know, right? It shows bitmaps. Like, it's not hard. And yet, look at how many people Facebook has doing that. In 2015, they had over 12,000. And you can say, well, oh my God, they've got an Android app and an iOS app. And like, what? And they've got their other like paper thing that they built or something. But how many thousand engineers on each of those things do you actually need in order to build this? Now again, I've been on Facebook for a while, and their motto was like move fast and break things originally, right? That's sort of what they got some good PR out of that for a while, and then they changed it to like move fast. As people got annoyed at how broken Facebook was all the time, they changed it to like move fast and be stable or whatever. But Facebook hasn't moved fast in a long time. It's been basically the same website forever, where forever in computer time is several years, right? I'm sure that they add a lot of things behind the scenes, like more ways to get people to click on ads and like analytics and stuff. But in terms of the user-facing thing, it's the same old site, except now with really annoying stuff that pops up, like, here's your summary of last year. Remember when you broke up with your girlfriend? That was really sad, right? You don't do that. So, let's not dwell on that. Anyway, I'm just trying to get to this. Maybe nobody at Facebook knows how to program either. And maybe that's not that surprising since they're also a web company. So you might say, like, well, these companies are successful, they make all this money. And my operating thesis would be, the only reason Twitter doesn't have 12,000 employees is because they can't afford to, because they're not making enough money yet, right? If they were making Facebook levels of money, they absolutely would have a Facebook number of employees with still the same Twitter that you have today, right? There's some kind of black hole that eats the ability to create things. So this is shockingly obvious to me and a number of engineers that I hang out with, but I feel like I'm standing here saying this, and it's a relatively unacknowledged thing in the Bay Area. Like, I don't feel like this is commonly understood, that this number is completely absurd. But it is. It's, okay. So, how do you avoid this, right? Like, you're here at school for computer science, and ostensibly, you actually learn some things. And some of those things are about how to build software well and efficiently, and how to have it be robust and to scale and all this stuff. In other words, you're kind of here to learn the right way to program, right? I knew how to program ostensibly before I came to Berkeley. I programmed in BASIC when I was 10 years old, and I sort of learned assembly language and stuff. But I came here, and then I really did learn a lot of useful things that made me a much better programmer and computer scientist. However, I would not say that when I left this school that I knew the right way to program. I knew better than I did when I entered the school, but one must always be very cautious. So here's the thing, is all those people at Twitter and Facebook that maybe don't know how to program that well, or are in an environment that's been constructed that prevents them from programming very well, most of them went to school and learned a lot of the same stuff. Yet those companies seem to not be able to build software. So what's going on? So when you learn this right way to program, or aspects of the right way to program, you get a bunch of techniques. And I'm going to go through a bunch of ideas that come out, right? And the thing is, when somebody teaches you an idea, let's say one idea is you should use functional programming, right? Because it minimizes side effects, and side effects cause bugs, right? Somebody will be teaching you this. And what they will be teaching you is the benefit of that technique. Because it was, hey, the reason people designed functional programming in the first place is because they observed problems with other kinds of programs and said, how can we get away from these problems, right? How can we scale to run on many, many, many more cores? Well, that's going to be very difficult if you have side effects interacting with each other, so let's get away from that, for example, right? The thing is, every single technique, and I'll go into some that are maybe even surprising, has drawbacks. They always, always do. And the thing is, the drawbacks are often subtle and they're very hard to see. And so when somebody's sort of selling you a technique in this way of convincing you that it's something that you should do, they're focusing on the benefits. And they're either going to be downplaying the drawbacks, or they'll be ignoring them completely because they're so subtle that they're not something that they talk about. And so the reason I'm going to show you all these examples is to sort of reinforce this idea that when you leave this school, you probably won't really know how to program either. You'll have some good ideas, though. You'll have a good starting point, but you won't have the answers. All right? So here's an idea. It's a very general idea, but look, if you want to program effectively, you should command your computer at a relatively high level, right? You should not get bogged down into implementation details because that's where bugs happen and you'll never get anything done, right? So the history of programming languages has been attempts to design higher and higher level programming languages to let you express more in less time, right? That's usually what languages try and do. But there are problems with that. There are all kinds of problems, and this one that I'm going to talk about is just one, and you could say, oh yeah, this other language doesn't have this problem, but it has other problems, right? So you probably can't read this. Probably nobody here can read this. This is a thing that happened, I think, last year. Google also has a lot of employees, but somehow their employees do a little bit more than people at Facebook or Twitter, so I'm not going to bag on Google here. They made a browser, right? That's a cool idea. Your web company, make a browser. And they've got a team there that was working on memory profiling for the browser, so you could tell what the browser's doing. It's a good idea, right? And what they noticed is in the top box in Chrome, just the place where you type the address bar, when you press a single keystroke, like the letter A, Chrome was doing 25,000 allocations, right? So calls to malloc and free or their equivalent. Now, they were ostensibly on Windows running a faster allocator, so it's not as painful as it might have been, but on mobile platforms they didn't for various reasons, right? So you might ask, how does that happen? And the way that happens is you program at a high level and you don't worry about implementation details. And in this case, a very relatively ugly thing happened where there's this thing in C++ called standard string that automatically allocates for you, and if you pass a pointer to characters to a standard string, zero terminated pointer to characters to standard string. I don't know. How many of you guys program in C++? Does this? All right, so you guys know what I'm talking about, half of you. Anyway, if you do that, it'll allocate, right? But then it'll automatically cast back to char star, so you pass it to a function taking char star, and you do enough levels of that because you have enough layers of glue code between one place and another, and you're just allocating over and over again, and then maybe you do that in a loop, and it gets crazy, right? So that's a large portion of what was going on. There's a few other things that are enumerated. You can easily look this up on the web if you're interested. I don't. When I program in C++, which is pretty often still, I'm trying to get away from it, but it's still pretty often. I don't use anything in standard because I think it's all bad. Okay, factoring your program and making abstractions. Well, that's a good idea, right? Because abstractions mean you can, maybe you did think about the details because you programmed a lower level thing, but then you want to supply a way for other people to use parts of your program where they don't have to think about the details, or even you 2 weeks from now don't have to think about the details, right? So there's this technique of like, let's put an insulating layer where the ugly stuff is all down here, and then this layer is nicer, and we talk to the nice part. Well, again, that's one reason why this happened, was because there's a lot of insulating layers, right? Another thing that happens, and I only thought of this week or last week, so or this way of expressing this. So I'm not sure that I'm going to say it very well, but the goal of abstraction is ostensibly to make your program simpler, right? Because you hide details and stuff. But abstraction actually always only ever makes your program more complicated. That is all that it does. If you are concerned with the program as a whole, which you must be if you're maintaining it or whatever, right? So here maybe I have some low-level code, and then I'm going to build an abstraction layer for some people to use it in a certain way, and then maybe there's an abstraction on top of that, and one on top of that, right? And then if I come along later, let's say I'm not the author of this code, but I'm coming along and trying to understand it, I don't only have to understand the low-level code, I have to understand all this extra stuff that doesn't even do the job of the real work that the code is doing. It's doing extra things, like plumbing, or how to translate to certain kinds of data structures. Some of that might be interesting functionality, but there's going to be all kinds of constraints flowing back and forth about when certain routines can be called and under what conditions and what types of values they return and whatever. And you have to understand all of that if you're going to understand this code base. Now that's not to say that you shouldn't abstract. You actually should, because it makes code usable, right? And if you can't make a good abstraction, that's maybe a sign that the low-level code is kind of garbage and like too complicated, right? You should be able to, but you should try to keep abstractions from being very bulky, right? I think they should be light, right? So it's a kind of a thing that you want to use in a limited way. And the problem, and I should have said the problem with all of these things, is it's very easy to get dogmatic about techniques and believe that you must use them heavily and all the time, and that everyone who doesn't do them is stupid, right? It's not true. All of these things must be used with care and with restraint, often. Okay, so here's a thing that happens when you abstract a lot. This is from someone's blog where someone was making an HTTP request in Java, like through some standard libraries. That I don't know which Java framework this is, but it's one of the common ones. This is the call stack. And this is the thing that actually does anything. And all of this is going into that and, yeah, whatever, interfacing, right? This is completely bananas, right? But this is what happens if you abstract. I would claim too much. The person who wrote this blog posting didn't actually mind this for some reason. He thought it was fine. So I don't know. But he was just interested in how all the modules were interacting. I would look at this and I'd be just like, I'm quitting computers. It's insane. I certainly don't want to try to come along later and try to understand this. Try to understand everything that's happening all the way through this stack. It's crazy, right? I mentioned functional programming, right? Here's another technique that you learn that some people are very dogmatic about. You should use functional programming, right? Side effects are bad. If you go on Hacker News right now, everyone wants to talk about Haskell. It's a cool new language. Haskell's the new thing. Everybody's going to be programming Haskell in a couple years because it's so awesome. But I hate to break it to everybody, but like Haskell is from 1990, right? This language is from when I was here at this school. It is older than that computer that I opened this talk with, all right? It's been revised several times, but this idea that you should program functionally whenever possible and avoid side effects, even in just Haskell form, has been around for that long, 26 years, right? There was also ML before that, right? And many other functional-ish languages and all kinds of Lisp and scheme variants and stuff, right? It's not a new idea that you should use functional programming and side effects are bad. So if it's been at least 26 years since that's been being pursued in a serious way, why hasn't it taken over yet if it's so effective? Well, it's not really, or it hasn't been figured out. So maybe one shouldn't be too dogmatic about it, right? My personal opinion is that clarity is extremely important. Again, if you come along and you look at a program, understanding that program as clearly as possible is really the most important thing. Because confusion is just what makes bugs. All kinds of bugs of all kinds of situations, right? Imperative programs are usually shorter and clearer. Well, trivial functional programs are short, but functional programs doing real work are usually hard to read and denser, right? They can be shorter because of very abbreviated notation, right? But that makes them harder to understand. So at least my personal preference, and I'm not going to try and sell you on this, but my personal preference is that imperative languages are a lot more understandable. And my first computer class here was on Scheme, where they wanted to do recursion all the time, and you know, I was really into continuations when I was an undergraduate. I thought they were like totally cool. Now I just think they're a confusing, weird thing that is an interesting curiosity, right? So I would be interested in functional languages, but I don't think Haskell is it, and we have to see. Data hiding. You should always hide your data because, again, you're hiding implementation details. You provide an interface, especially if you're programming an object-oriented language. You might have classes and use class interfaces, right? That's fine, but this has consequences, both redundant with what I was talking about before, about over-abstracting and that being a problem. But it also has performance problems, as I found working on my past couple of video games, right? I don't use very heavy object-oriented techniques, but I do use C++. I use single inheritance. My class hierarchies are like 3 levels deep. In very, very rare cases, do I get more than that? Usually they're 2 levels, actually. No, 3 levels. But the bottom level doesn't even do anything, so why is it there? I don't know. But it turns out, when you divide your stuff this way, when you have like, oh, I've got a class representing a thing, you're going to get very bad cache performance. You're going to get, I said pots of boilerplate. It's supposed to say lots of boilerplate code. That's probably a spelling correction problem. Over many years of practice, I've learned how to massively reduce the amount of boilerplate code, but I still have poor cache performance, and there's not really a way around that in C++ if you're going to use inheritance at all, right? So I'm making a different programming language to get around that. And in general, when you structure things this way, you get a very poor handling of what's called cross-cutting concerns, right? And I put this in quotes because, you know, this is a well-understood phrase among programming language people, but I don't like it too much because it sort of trivializes this idea. Like, oh, you've got your program and it does a lot of things, and there's just some concerns that are cross-cutting, where cross-cutting means, oh, maybe I've got one class that does a lot of things and another class that does a lot of things, and there's just a few concerns between them that cross boundaries and there's no clear place to put it, right? That's not really how it is. Actually, most of the interesting things in a substantial program are cross-cutting, right? So it's like the non-cross-cutting parts of your program, when you can isolate them, you should feel lucky. Like, oh, here's a gem that I can crystallize. But everything else, especially if you do video games, which are very intensely they're simulations, so everything affects everything else, and every system wants to know about every other system, right? They're very intertwined and interconnected. And so almost everything we do cross-cuts with almost everything else we do, especially when you care about performance. Again, for C++ programmers, there's this thing called RAII. Oh, by the way, so all of these things that I'm saying are also things where, you know, one sort of field of programming language people or religious sect will say, yes, this is a very important idea, you should structure your program around this. And somebody else will say, no, that's completely bananas, that's obviously wrong, right? So some people in different programming languages would say, okay, oh, obviously this is going to happen, but C++ people would say, no, you should use, well, maybe, I don't know. Java people which say you should use classes. The other crazy C++ people would say you should use template metaprogramming everywhere, which is also not correct. RAII, which is I believe this term was formalized by the C++ people, but again, it's a relatively common thing. It's like, oh, it's hard to keep track of state and reverse your state correctly, so we're going to make it so that you can only construct an object in a valid state so that there's less to think about, right? And then, we can unwind the stack in a clear way, like when exceptions happen and whatever. Again, when you start programming this way, you get tons of boilerplate code, but you also have a problem where, again, you can't make your program very fast because your program has this way of thinking about resources that is very slow and clumsy and prevents you from doing more than one thing at a time. And if you start doing more than one thing at a time, which you do any time that you're making a program fast, this just completely falls apart. Exceptions, which I just mentioned, right, are crazy. I think they're the worst idea in computers, and there's a lot of bad ideas. The reason exceptions exist, I mean, there's sort of two different kinds of exceptions, and here I'm talking about the there's a certain kind of exception where it's like, oh man, the computer's broken or something, and the program didn't execute, right? Or your spacecraft is going, and there's like 3 chips computing things, and they're supposed to all agree, and eventually one of them doesn't agree because a cosmic ray hit it or something, right? I'm not talking about that kind of exception. The kind of exception that's a bad idea is this convenience thing where it's like, oh, I'm writing a sound library and somebody wants to play a sound, so I'm trying to load it and I couldn't open the file, so I'm going to throw because I couldn't open the file, right? That's crazy, because what you're supposed to be able to buy from that is like, oh, it's a little bit better way of reporting errors, right? You don't have to like pass error information redundantly up many levels of glue code. Why do you have that many levels of glue code? You shouldn't, right? But if you do, you don't have to do that. You can just sort of go directly to jail, right? Do not pass go. The problem is, once you make that choice that's in your language, then you either have to make, assuming it's a strongly typed language. If it's not, you shouldn't be using it anyway. But if it is, you either have to put verbosity everywhere about what can throw what, which gets increasingly complex and unwieldy to the point where just forget it, your program falls down. You can't type anything anymore. Or you have to pay this constant cognitive tax of exception safety where it's like, I don't really know what my program's going to do between this part and this part, so at all times I have to be on guard against somebody attacking me with an exception, right? Which is part of where this RAI idea came from, but it's just crazy. Like, it's already hard enough to program. To pay that tax everywhere for what is at most a minor convenience is crazy. So here's one. This is my favorite one on this list. Actually, because I'm listing things. So remember, it sounds like I'm saying a bunch of negative things, but the reason I'm focusing on the negative things is because you mostly hear the positive things, right? So there are some positive aspects to exceptions. There are some positive aspects to RAI. I'm not trying to say they're wholly useless, although some of them are more useless than others, for sure. Commenting your code. How could anybody ever say commenting your code is bad? It's usually good. I think people should write comments. There are a lot of ways in which commenting your code can be bad, though. One of them is any time you spend commenting is time that you're not programming. That's obvious, right? So you are, hopefully you don't spend that much time writing comments, and hopefully you spend most of your time programming. But whatever time you spend writing comments has to be earned back later, right? People don't think about that. In order to even break even, your comments have to be useful enough to save that much time. Now, usually they will be, especially if you write libraries that a lot of people are going to use or something. But then there are problems, like comments often get very useful comments. There are stupid comments, like I++, semicolon, comment, increment I by 1, right? That's completely useless and stupid. That kind of comment just creates noise and makes the program harder to understand, so that's a net negative. But comments that are useful are actually expire very quickly, right? So if I'm saying a lot of things like, okay, only call this routine when such and such state has happened and we haven't set Bisley Bob, and if you expect to do things this way, then fine, but if you expect to do them a different way, call this other routine that is going to be faster in that case. That, you might have a paragraph-long comment that says that, and that would be very useful for 6 months or a while, depending on how fast your programmers are. At some point, many of the facts in that comment are no longer true because the code has changed, right? Now, how do you know that? Because the compiler doesn't run or type check the comment ever, right? The compiler type checks your code, so your code doesn't rot that easily. But comments are code that never runs and is never checked until somebody goes and reads it and gets really confused, and actually it takes them longer to understand what the hell is going on than if they hadn't read the misleading comment, right? So comments rot. So if you're going to comment code, which you should, you also have to invest time in gardening the comments, right? You have to maintain them and keep them up to date. I don't know anybody who does that systematically. It just, people wait until the comments get old enough, then they just get angry and delete them or something. So there are downsides to everything. That's the reason I put comments in here, is commenting seems like such a no-brainer. There's other downsides to commenting. I mean, they're much smaller, but your program's going to take longer to compile. Maybe a very small amount longer now, but your lexical analyzer has to crank through more characters. If you're in a terrible language like C++, it might have to, in the comments in a header file, you might end up hitting that comment 50 or 100 times when you try to compile. It's still kind of trivial, but you shouldn't, if you're actually doing a cost-benefit analysis of any of these techniques, you don't want to ignore anything. But you may look at that and say, okay, I don't care, I'm willing to pay that cost. But you need to look. In general, one of the holy grails of software engineering is code reuse, right? Somebody worked so hard to write something, and you shouldn't have to do that again, right? You should just be able to use it. You should be able to build other things on top of that thing. And look at all the great stuff that we built that way, like the World Wide Web, which is like, PHP running in Apache, which is like running in a container on like Linux, and then JavaScript in your browser, and like all these things, just to put some text and a picture on your screen. I'm going to claim that the reason the web feels bad is because we don't really understand how to build things on top of other things, and it usually doesn't work that well. And the more stacks of things you have on top of other things, the more it's like Jenga or something, where the top is really wobbly, and if you're going to change a block in the middle, you stand a very large chance of knocking it down, right? Anybody who's worked with these systems seriously knows what I'm talking about. So I just want to say, code reuse is a good idea, yeah, except it's not. I get pissed off at things that try to reuse code all the time. For example, I've got this really simple shell here called Commander, which I still have installed on this laptop, but I rage uninstalled it from my Office machine for many reasons, right? Because it was causing me problems, right? First of all, every time I try to go and configure it or something, it's built on some whole other thing called conemu. It's like some thin display interface, and I don't know what conemu is. I don't want to care. Right? I want Commander to be as simple as it possibly can be in exposing its interface to me, but it's not, because there's this conemu thing there making it more complicated, right? It seems to involve Git in some way, like it's when I don't know if exceptions are being thrown or something weird happens, and it drops to some kind of weird Git prompt, and I don't use Git, I don't want to use Git. So that makes me angry. This also uses Perl. It drops to a Perl Git prompt, by the way. I don't know what that's all about, but apparently a lot of it's written in Perl. So it's like, oh, cool, use a higher level language, right? It installs Perl on your machine and puts it in the path. And you may want to install Perl for your own purposes, and they may be different and incompatible versions of Perl, which will then cause you a great deal of confusion if you're trying to get ready for a demo, as I was one day, and wanted to do real work, but I spent what seemed like many hours. It was probably really 45 minutes, but just what the hell is going on my machine? This is crazy, right? For this thing that's just a console, it's just for me to type commands, right? It starts up really slowly. For some reason, a few versions back, they decided it would be cool to pop up a new version detection box to try and get me to download an update to the new thing. I just want a command prompt, right? Now there's a box that I have to hit enter. It crashes for mysterious reasons, not the Perl Git prompt crash, but a different crash where it just completely disappears, right? I know computers pretty well. I could figure all this out if I wanted to invest that time, but I don't, because I'm a busy person. It's just a console and I want it to work. But it is a very typical example of things built on top of other things, right? If I was going to make a console, I would definitely use some things. Like I would use the operating system's display library, whether that's OpenGL or DirectX or something, right? I would use I wouldn't use a font render. I have my own font rendering stuff, but I would certainly use the TrueType file format or whatever to read the font. There's certain layers of reuse that work, but reuse does not work to the degree that we try to employ it. And this is a major, major problem. And again, just like nobody seems very concerned with why nobody at Twitter and Facebook seems to know how to program, nobody seems to be concerned with the fact that we don't really know how to build things on top of other things. We just keep doing it. We just keep doing it, right? So the web is a giant mess, and I don't think it's going to get better anytime soon because everybody's solution to making it less of a mess is put more things on. Hey, WordPress is really slow, so put a cache in there, right? Oh, your browser's really slow, so let's pre-compile the JavaScript on page load, right? And then maybe some of it all the way to assembly or whatever. It's just crazy. You don't make things better by making them more complicated. So Commander to me feels like the web. They feel like the same thing, and it really drives me bananas. Okay, I knew at this point that I was going to be worked up. So I'm going to try to calm down and conclude. So there isn't, right, it's easy to come out of school with feeling like you're smart, because you are. You know, if you got here and you're able to get through these classes, you're able to figure some stuff out. You know, you're able to do some stuff with computers, and that's all very cool. It is very easy to get a big head and say like, oh, I'm going to go out in the world and I know better than most. Twitter is obviously stupid. Look at, they could barely do anything. I'm going to go out and do something better. And maybe you can, but also take a certain measure of caution, because actually very, very few people, or probably zero people, either in academia or industry, know how to program right now. We're kind of, I didn't put a title on this lecture, but I almost called it the dark age of programming, because I sort of feel like we're in one, because the more you know about programming, the more you realize that everything we do is like really scary, and everything like barely works. And if you just like kick it, it's going to fall over. Some things have worked. I don't want to be a negative Nelly through the whole thing, right? Most of these are really old ideas, but these are a couple of the things that I think have been the most effective in the history of programming, right? This idea, hey, we shouldn't program in assembly language. We could use a higher level language, right? It was also called, well, there was one slight step beyond this called structured programming, which was just like, don't use gotos everywhere, like use loops and ifs and stuff, right? That was a major idea back when it happened, and it's been very effective, and I don't think anyone wants to go back from that, except a few friends of mine. But only on occasion, like, you know, I mean, in games, people still program in assembly sometimes. And if you're writing shaders, you may program in assembly often. But it's a fake assembly, so I don't know. Anyway. Static compile time, strong type checking is another idea that I think is very successful. It's more controversial because there's probably still people at this university who think Lisp is great or Scheme is great or whatever. If you have a strongly typed at compile time variant of Lisp, then I'm all in favor of that. But if you don't, just run away. Like I said, it's more controversial. A lot of people will disagree with me, but I think this is one of the most successful ideas in the history of computers, right? So it's not all negative, but these ideas do not come along very often, right? The massively successful ideas do not come along very often. Maybe I should put code commenting on here, because it's very successful despite the drawbacks that I mentioned, when employed correctly. But it's sort of too obvious of an idea to make this list. But all this other stuff, you know, reuse, exceptions, you know, data hiding, functional programming, all of these are contextually useful. And in your career, you will find yourself in many contexts. And even one program has many contexts within the program. And in some contexts, certain techniques are going to be useful. And in other contexts, if you blindly apply those techniques, you're going to be digging yourself a hole, and you'll be very sad. But then the extra thing is, if you try to mix together too many programming paradigms, then you just get a big confusing mess. So it's very hard, right, to program well. I said possibly nobody in the world knows how to program well. You can try though, right? It's very difficult, and it just requires constant vigilance. You need to keep checking your assumptions and checking your ideas about how to program. And that's all that I have to say. I don't know if we have time for Q&A or what. Yeah? Okay, we'll do some questions. Anyone? Yeah.
How did you start into the video game industry, deciding to make a video game and sort of saying that's going to be my profession seems kind of like a hard thing to do. How did you start?
I did exactly what you just said. I decided to make a video game and said that's going to be my profession. Although I didn't have that much of a look ahead. So I said, oh, I'll make a video game. I actually started a company with a friend who I'd met here at school, and We didn't know very much about games, and we had a lot of problems at that time, but it was also the biggest learning experience. Like, I learned way more doing that than in school, but also if I hadn't done school, I wouldn't have been prepared for that. So when I say that, I'm not, slagging on school. I'm just saying there's so much to learn past that. Yeah.
How will we know when we are programming well? What's the test? That's beyond what we can say we are now programming.
You don't, if nobody really knows how to program that well, you can only compare yourself relative to other things. So compared to where you were, so I can look back at what I thought was good programming when I started that first game company, right? So in college, I thought I was a good programmer. I thought I was one of the best programmers. I did all these personal projects that were way more sophisticated than anyone else. I like to make little programming languages, so I would build languages. I think when I sort of stopped working on it, the most complex thing I had built was a 14,000 line program that was an interpreter for my own language, which in college seemed really big. I don't know what you guys do these days, but back then it seemed really big. That is a trivial program compared to what I do now, right? So I thought I was real smart back then, but I would look at what I was doing and I'd say, that's not that interesting, and what you're doing it in a dumb way. Stop it and do it a different way, right? So as long as that keeps happening, as long as you can keep looking back and seeing how you've improved, then that's good, right? If that ever stops, then you maybe question what you can do. You can also do it by looking at other people, and I did that. And I'm trying not to be mean about it because I don't know what it's like socially at Berkeley, but back when I was in school, there was a certain mean-spirited show-offiness that sort of pervaded programmer culture, right? Because you want to show that you're good at it, right? And there's this it's almost like an extension of the high school social thing, but among programmers, where you're like showing how badass you are all the time or something. Wait, why was I saying that? I just got lost in reverie. Anyway, it's very easy, especially coming out of that environment, if it's still that way, to kind of be mean-spirited. And I don't think that's productive. So you don't really want to be like Linus Torvalds or something and calling everybody an idiot. However, I also believe in calling it like it is, which is why I feel pretty safe in saying that nobody at Twitter knows how to program. No, that's again a little bit mean way to say it, but like, whatever environment has been established at Twitter, I'm trying to find that graph of employees, whatever environment has been established there that keeps 2,000 engineers from doing more than the current website is destructive and poisonous. And let me put it this way. So I just mentioned when I started my game company, it was pretty close to out of school. I did one other thing. I did like a less than a 1-year contract. Actually, 2 other things that were small. We started a company, and we really didn't know how to make games at the start of that. And it was the very most difficult time to start making games because you didn't have graphics accelerators or anything that would draw graphics for you. So you had to learn how to do 3D graphics pixel by pixel, which is not even what they taught. I never took a computer graphics class in college, but back then they didn't teach that stuff here either. You would like use OpenGL to draw triangles. That was like what they taught. So you had to figure that stuff out, and then you had to figure out how to do it fast. And then you had to build a game around that somehow worked. It was like revving a fast car on redline like all the time. I was learning so much because I was being very, very challenged, right? If you go into a big, boring company that's not doing very much right out of school, it's when you're ready to learn things, to keep learning and to get a lot better, right? To just keep take the learning that you've gone here and keep extrapolating that line. And if you go into a very stodgy environment or one where things don't happen very well or where you can't do things very well, you're not going to be able to learn that well. And you're going to become a worse programmer than you would be. Like, I can say that pretty definitively. Like, the difference between somebody who goes into a challenging environment versus a boring environment is stark. Now, all this said, so I've said all this stuff about Twitter. Again, I don't know anything about Twitter. I don't know if I know any programmers at Twitter. And I bagged on Facebook, too. I don't know anybody at Facebook. I know a couple people at Facebook. Not anymore, though. That's not what I meant by that. That would be good. Probably not anymore, really. But I'm just looking at, output versus input, right? and it's insane. So I don't want to be mean about it, but I also, so I feel like there are ethical issues involved in all this, right? Like you guys all deciding what you're going to do with your life when you come out of school it's an important time, right? And so I feel like it's important to warn you about certain things. If you're going to go someplace and it's going to make you a crappy programmer, I'd rather save you the year or two that it might take you to figure that out, if you even notice before it happens. So this is a massive overgeneralization, but it's mostly true. Just don't go to any company that does web stuff. Go do something else somewhere else. Or even if you go somewhere like Google that's ostensibly a web company, just make sure you don't work on websites. Make sure you go do like cars or AI or something cool like that. They've probably got a Google rocket ship they're working on in private, right? Do one of those. Do not work on websites because they'll kill your brain. Okay, yeah, other questions? Just cut me off when we run out of question time, by the way. Over here.
I have a question. You talked about a lot of problems and you made a pretty good case for them, and I think I believe you, but I don't see like solutions beyond being aware and having better programmers. Like,
yeah, that's well, and then
I wonder if you do.
No, I really don't. And I mean, the thing is,
I guess that's kind of what you're trying to do here, to some degree.
a little bit, but I can't do very much, right? By giving a little talk. So there's a similar thing that happened in the games industry, even. So I'm a big believer that your environment helps shape you tremendously, right? That's not a very controversial statement, I don't think. And the environment in making video games has changed a lot. So like I said, when I went into games, it was the absolute hardest time. But all the people I know, not all of them, but most of the people I know who are the best game programmers came from that time when it was very, very hard. And to get anything done, you had to work really hard. And it was kind of brutal. I know some people who are from a little bit later times, but you know, for the most part, the best programmers are from the 90s, and we're getting old in games, right? And so that shift happened. So, you know, and what happened is it got easier to make games. There's all sorts of tools you can use. If you don't have very high standards, you can use, you know, garbage collected languages or something, and you take some frame hitches once in a while, but you just choose to ignore those. And it's basically easier. It's way easier. You don't have to do all that pixel by pixel stuff I was talking about. But because that challenge isn't there, it also means that people are not forced to rise to that challenge because it's not there anymore. And if you don't force people to do a certain level of discipline, they won't do it themselves, right? They won't. Very few people will drive themselves as hard as they would if they were being externally driven. And so in games, I feel like we don't have as many good programmers as we used to. It's not to say that we don't have good programmers, but there's a difference, right? And so when I say don't go work at a web company, it's analogous, right? It's like I feel like the environment there is not conducive to careful thinking or even understanding the system that you're working on. How could you, right? Nobody can ever understand everything between JavaScript on the client and, you know, the CPU on the server, right? I mean, the CPU's running UOPS, so good luck. Good luck even understanding only the CPU on the server and nothing else. And so this insistence that the web has of trying to make things better by piling more and more layers makes it a worse environment for being a good programmer because you just can't. It becomes more and more about blindly flailing at things and trying to hit them until they work, and that's not good. Okay, someone back here had. I don't want to bias toward the front of the room all the time. Okay. Yeah.
All right. So, from your point of view, like, would you say like if you want to get into game dev, would that be a good career choice? Because I know we have some game developers in this audience. and I just wanted to get your point of view because, like, I don't know.
Well, I mean, I prefer it, but what are you interested in? If you want to make the most money, the answer is no. Unless you get really lucky or build your own thing, then you can make plenty of money, right? If you want to do creative things, or if you want to do technically challenging things, it's a very good place to go. So, I mean, games are probably some of the hardest things to make work in the world. Yeah.
As a web developer who's gotten relatively comfortable in this sort of mess, and it's something that I have to like live with if I want to continue.
You don't have to though. It's
right. If
we all have to.
If I wanted to continue building stuff for the web, it's something I have to live with.
Yeah.
So, what, in your opinion, what's something that I should be aware of, or I should take into account whenever I work on web-related projects to sort of mitigate the bad things?
It's poisoning your brain. Be aware. It's like radiation, where the longer you're exposed to it. I mean, I don't know. I stay away from web stuff as much as possible, so I don't think I can give you very practical day-to-day advice because the web makes me so mad. I can't even begin to do anything on it anymore. I mean, I do it as little as I can. I mean, I would just say there's maybe some universal advice though, which is just try to understand the system that you're working on. Even though it's impossible, if you understand a little bit more about it than you did yesterday, then you'll naturally find yourself coming up with better solutions and more out-of-the-box solutions than other people might have. And you might eventually see a way to make things better. Although after you think you see that, wait 5 or 6 years until you really see ways to make it better, because again, the problem with the web is people are just spewing, here's a new JavaScript framework this month, right? It's amazing. Everybody should use this JavaScript framework. Well, very rarely do people pop up to the meta level and say, if these frameworks are so great and helpful, why do we need another new one? Why didn't the last 27 frameworks solve the problem? They didn't, so you need the 28th framework, right? And tomorrow there'll be the 29th framework. So don't make another one of those. But if you live there long enough and just be smart, you may be able to. The web certainly isn't going away, right? And so hopefully it'll get better over time. And how does that happen? I don't really know, but yeah. Let's go way to the back. So I'm going over here. Yeah.
What are your favorite games?
Oh, I don't want to spend time at a computer science talk talking about that. I generally like games that are creative and do something imaginative and new. I'll just say that. Standing up back there.
You brought up the idea of Ludo narratives, so like narrative
That. Stop the question after the word ludonarrative. Like, I don't.
Yes.
That word it's indicative of a whole line of thought that I. So there's this really old movie called War Games that was from before anyone here was born. The computer says it's a strange game. The only way to win is not to play. So that whole line of thinking about games in that way. The only way to win that is not to play. So I think if you look at games seriously in a very detail-oriented way, there's just a lot of things to be interested in, and most of them don't involve the words Ludo or narrative. It's just how I feel about it. Sorry. Over here.
You say you don't use Git. What do you use for version control?
I use Subversion.
Okay.
And the reason, and I have to tell people this every time they ask me why. So the reason is, things like Git are not naturally very good at handling binary assets, right? Well, there's multiple problems. The other reason, before we even get into that, is that I work in an office with some people who are not technical, right? And they're just doing 3D modeling and drawing cool pictures and stuff, and they want to get them into the game. And you can't really force those people to use Git. Something is going to go wrong, even if you use like a Git UI client, right? And then they're not going to know what to do. They're going to have to bug me, and I'm busy thinking about something. So that's thing number one. But number two is it does not do very well at large binary assets. So our repository for this game, just the local copy, is about 85 gigabytes right now. And maybe it's up to 100, I don't know. But that's just the current copy, right? We've got build machines. So we've got a world full of all sorts of cool stuff, right? Objects in the world. And the way we do lighting in that world is we pre-compute, we bounce lights around, right? And then we take a surface map on the thing and we save that out as a 2D bitmap. And there's a machine that updates all that so that people make changes to the world and then they check them in, and then the machine checks that stuff out and like bounces the light around and checks that back in, right? So 24/7, there's a stream of new binary files coming in of like updated light maps for all this stuff in the world, right? And that's exactly the kind of thing that Git is terrible at, because you'll just run out of space, right? Like immediately. And you'll just be spamming the network with, I don't know, it'll be crazy. So now there are workarounds for that. For Git and Mercurial and stuff, there's like ways of storing your binary stuff on like a side repository, and everyone who evangelizes Git is like, oh, it's great, why don't you use that? And it's like, well, because then your code and data aren't really in sync, and the problem is they need to be. Like if you change a file format and you save the file out, the code that reads the file has to be exactly in sync with the file. If you step back to a thing and you get one and not the other, you're in trouble, right? So, I mean, if the solution is really manage multiple repositories that work differently, anyone can do that with any source control system, and you're just inviting a lot of problems again. And then again, the non-technical people are going to go crazy as well. Okay.
You mentioned a lot of times you know, the scale and size of like game projects being very different from say like web stuff that Facebook and Twitter does. So do you find that there's a lot to be like learned from like some of the game industry practices of programming?
If you want to do certain kinds of things, yes. I mean, the stuff that we're good at is making a program respond very quickly to input, right, in a real-time way, while it's doing something very complicated, right? So like this dude is talking about how like a Facebook feed is supposed to be complicated or something, but you know, you play a high-end AAA game, and like 60 times a second, it's manipulating a couple gigabytes of data, 60 times every second. And like making the buses of that computer like hum and like deliver all the stuff as scheduled, and like it's a whole different idea about what you can make a computer do, right? So if you're interested in that, games is a good place to do that. It's one of the best places to do that. If you're interested in building very high level, very abstract things that don't care about being interactive or real time, then there's probably other places, right? So if you're a neural network research person and that's what you think is cool, I mean, you could apply neural networks to games, but you can also apply them to a lot of other things. So, yeah. But definitely part of the reason why the web bothers me so much is because I know what computers can do. I wasn't kidding when I started this by saying this is an insane supercomputer compared to what I'm used to, and we don't do anything with it, right? This is an incredibly insane supercomputer, and like it takes forever to boot and runs Photoshop. Yeah. Anyway, beating a dead horse. Okay, you had your hand up a couple times.
Yes.
Yeah.
How do you stay motivated to keep on top of your game? And sorry, multi-part question.
Yeah.
So how do you do that? What tools and sources do you use? And how good are you at it?
How good am I at using tools and sources, or how good am I at staying motivated? Okay. Tools and sources is hard to answer because it's all, I'm not going to be able to give you a very good answer there because A, it's pretty specific to what I do, but B, that stuff changes kind of rapidly. So, you know, I use Visual Studio to program on Windows. The reason I program on Windows is because debugging on all Unix operating systems is worse enough that you pay a constant tax for trying to program there, because it's just harder to visualize what your program is doing. And I can barely get games done on Windows. So like, I want to switch to Linux, for example, because it's an ideologically better operating system. But in practice, the community making that operating system happen does not seem to value enough productivity of development, which is crazy because if they increase their own ability to get things done, they'd be able to get their own operating system done, but whatever. Anyway, so Keeping motivated is interesting. So I actually used to be very demotivated very often. So I mentioned before that I actually dropped out of this university. I was pretty close to graduating. I needed to be here like one more semester. But I was so demotivated to keep going to school that I couldn't make myself do it. I just had to leave, right? So it wasn't just lack of motivation as in like stopping. It was like also associated with some kind of depression, right? And I don't think that this is an uncommon thing. I think computers, as we often use them, very often make people kind of depressed. And I don't think that's too surprising, but it's also not very well understood why, right? And so I think if you're going to be a serious programmer, you need to, if that happens to you, which it happens to many people, then you need to observe exactly what's happening and learn to recognize it, because at first you might not even, people just react to stuff, right? You can drop back a step and say, oh, I see what's happening here. It's just this mood happening, right, that I've had before. Maybe that means I'm still going to do what it's telling me to do, which is stop working on what I want, but I'm at least observing it, right? Observing it is the first step. And then for me, that kind of thing got a lot better when I found what I really wanted to do. Because what I discovered was, I thought all through school and then early jobs that I would do and stuff, I did a lot of contracting. After that first company that I had went out of business, I did a bunch of contracting and stuff. And I was really excited to get there and work on a new project. And then after a couple of weeks or a couple of months, it would start getting old, and then I'd just not really be able to do anything. And they're paying me to do stuff, and I'm not doing it. And I don't like how that feels, but I'm still not doing it, right? And human psychology is complicated and weird, right? But what my interpretation these days of what was going on was just that, I have some subconscious mechanism that really wants me to be working on the most important things that I could work on. And if I ever wasn't, then it would just stop supporting that activity, right? There's some part of me that, even though I thought I wanted to be there, like, oh, I'm making plenty of money, it's cool to work on this game or whatever, part of me really thought it wasn't that cool, right? And took away support for that activity. So once I started doing my own stuff and did it in such a way that I was not afraid of commercial constraints or whatever, like you could imagine starting your own company, but then because you're so worried about making the company go, you build things you don't really want to build because you think that that's what you could sell or whatever. But I didn't do that. I made exactly what I want to make and the way I wanted to make it on the time scale that I needed to make that happen. And ever since I started doing that, I don't generally have motivational problems. It's completely, depression kinds of things are completely gone. Just that, like, I'm in a boat and the wind has stopped and I'm just sitting here is gone, right? Now, I do still have ups and downs. Like sometimes I'm really into it and sometimes I'm like, I don't really want to work today, but I kind of gotta. But it's not that same like paralysis. It's just like, oh, I've gotta, I know this is a low day, but I really believe in what I'm doing. It's the best thing that I know how to do, so I'm going to keep going. So that's all. People say do what you love, and it's really often taken as hokey advice, but I think computer people especially need to do that. Because like I said, there's a certain kind of depression that is endemic in this kind of situation. I mean, I don't know. Again, I'm not going to school in the year 2016, but I imagine it looks kind of the same from a certain dimension, right? So I imagine that hasn't changed very much. I don't know if any of that's useful, but yeah. Back. Yeah.
On the topic of productivity, what are your thoughts on books like Design Patterns by the Beginning of 4? Do you think that's valuable or harmful for the engineers just trying to get things done?
Again, the thing with Design Patterns is the only way to win is not to play. But, so all of this kind of stuff, even, the worst advice, like some advice that I totally would disagree with, like, oh, you should use RAII on all your stuff, right, is bad advice unless you're so beginner that that's good advice, right? And so if you really don't know anything about programming or know very little, and have written a few simple things, something like design patterns could be very useful. It can give you a framework for how to think about things. That framework is also kind of poisonous, but it's also giving you some structure and helpful, right? School's the same way. I think going to school here for computer science is way better than reading something like design patterns. You'll be exposed to probably a broader variety of opinions and depths of ideas, but they're not all right, like I was saying. And in fact, most of them are partially right and partially wrong. And so really what you want to develop is the tool of judging what's right and what's wrong about everything. And so I think the thing about a book like Design Patterns is it's hard to do that. Like a book just telling you stuff is hard to judge because it's just words, right? The thing that really lets you judge is when you go use things in the field and you just see how it went. And even then, it's often hard to see how it went until way later, because you might think something's really successful, but then 5 years later you're like, you know what, if I went back and did that, I could do it 5 times faster if I did it a different way. So it's hard. I don't know. I feel like I'm talking a lot. Should we do like 1 or 2 last questions, maybe? All right.
Whatever you like.
Two more. Yeah.
How do you balance your desire to do things right and well against getting things actually done?
So I go way toward the doing things right end of that spectrum. Like I just took frickin' 7 years to make one video game. It's a very complicated game, but I wanted to do it right, and I didn't want to rush it out and stuff. And I'm very happy with having done that. I wish I could make things of the same complexity faster, and I'm going to be working on how to do that. But I would rather make that quality of thing faster than make a low quality thing really fast. But everybody has to make their own decision there, so yeah.
So it seems more philosophical than anything else.
Yeah, I mean, you just kind of have to decide what you want out of life, which I can't tell you. I will say working on something a long time is really hard, and not a lot of people can work on a game for 7 years with no external validation. I had a warm-up because my previous project took 3.5 years. So, it's like building muscles at the gym. They get stronger for next time. But like I said, there is this environment of like being depressed around computers that we have to be careful about. And something about making games makes that even harder, because if you're an independent game person, you're trying to do everything by yourself. So when things aren't going that well, you feel like it's your personal failure, right? It's different than if you're at a company and you're just not motivated, or if you're at school and you're just not motivated. It's even harder. So you just have to pick and then do it and not give up. And I don't know. Okay, last one. Wow. Who really has a really important question? Who's got the most important question?
I know.
All right, I'm going to take the sweater dude toward the back. Sorry, other people. Yes, you. Yeah.
I don't know if I hold up to your standard, but
all right, well.
What was your process like for designing the puzzles in the witness?
I've talked about that. Let's take a different question, because I've talked about that at length, and I can send links to what they are. Because it really is like an hour-long answer. That's the thing. And I can do that. Okay, different question. I do agree that's a good question, but I just don't want to do it. On the right.
I don't know if this is similar to that, so maybe I can get
on the left. Okay, yeah.
Me?
Yeah.
Okay, well, I had 2 questions, but I guess I'll pick between them. One was about Jai, but I guess maybe people can just read about it on your GitHub or something. So I guess what's your personal opinion of like the creative people you work with, like David Hellman on Braid and your team on Witness?
What's my personal opinion on them? You're asking me to judge them as people?
Okay, what do you think of them as people, I guess?
Well, I mean, they're all really talented people, first of all, which is not easy to find. Okay, so this is another one of those slightly politically incorrect things to say, given the audience, but I'm also on an investment fund where we invest in games, and often what happens is you'll have a group of friends come out of a school and they want to make a game because they work together well on projects or something. And usually there's like 1 or 2 people in that group who are like the important people, and everybody else is kind of dragging it down. Because everybody wants to be friends with their friends, or wants to keep the band together or something. And in reality, maybe those other people are perfectly good, whether they're technical or artists or whatever, but maybe they should be doing something besides a game or whatever. But we've just seen this pattern over and over again, where some people are the real people on the team, and then the other people are kind of hanging on, right? Which is just a way of saying that if you can put together a bunch of people who are good at what they do, then that's very lucky, because it's hard. It's not the natural state of things. If you pick a random group of people, even at a school like this, you're not going to get a good team, right? So I feel very fortunate to have been able to work with people who are good, right? So Braid, I was kind of doing the art for Braid as programmer art before David came along, and it was pretty ugly. I could have found another artist to work on it. I don't think it would have looked as good as what David did, right? So that was very lucky. Similarly, when we started The Witness, I thought it was going to be an ugly programmer art kind of a game because I had relatively low expectations of it. But then we were able to make it look really nice, I think. It's a very beautiful game. And so again, it was lucky. And also the programmer is working on it. We built an engine from scratch, and it runs very well, and that's not easy. So you just have to feel fortunate whenever you can make that happen. And so break up with your friends when you leave college. No, that's not true. Just be careful about it. All right, thanks for having me, and I can hang out and talk individually.